Let us solve this problem in beta function. Show that integral 0 to pi by 2 d theta by sin theta into integral 0 to pi by 2 root sin theta d theta is equal to pi. So previous video we have done one class in gamma, one problem in gamma function. So same way, this I will take it as integral 1, this I will take it as integral 2. Finally I will multiply these two to get the answer. So I'm going to write I1 is equal to 0 to pi by 2 d theta divided by root sin theta. So I am going to bring the sin theta to the numerator. So it will become sin power minus 1 by 2 theta. Because root sin theta is sin power 1 by 2. If it comes to the numerator, it is sin power minus 1 by 2 theta. I am going to compare it with the formula. Comparing this with, you have two formulas for beta of m comma n. The first formula is integral 0 to 1 x power m minus 1, 1 minus dx. Here it is not going to, is this matching? Nothing, everything is in terms of theta. So I am not going to use this formula. What I am going to use comparing this with beta of m comma n is 2 into integral 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. So now we are not with, so let us, I'll erase this. Yes, now you don't have any confusion. We are not using the first formula. We are using only the second formula. So now 1, 2 is missing. So if I push this 2 down, okay, so I will take this 2 from here and then I'll push this down here. Okay, so beta of m comma n by 2 is equal to integral 0 to pi by 2. So I'm comparing this sin power 2m minus 1 theta. In the place of 2m minus 1, what I have? 1 by 2. So I don't have anything in terms of cos. So I can write it as cos power 0 theta. Because anything power 0 is 1. So in the place of 2n minus 1, what I have is 0. So your question I1 is nothing but, very simple, beta of m comma n by 2. So what is this m and what is this n? To find this, we are using this comparison. In the place of 2m minus 1, I have minus 1 by 2. 2m minus 1, I have minus 1 by 2. And in the place of 2n minus 1, I have 0. From this, I can take what is m. So from the first equation, 2m minus 1, 2m is equal to minus 1 by 2 plus 1. 1 minus 1 by 2 is 1 by 2. Therefore, m is 1 by 4. 2n minus 1 is 0 means 2n is equal to 1, which implies n is 1 by 2. I'm going to substitute these two here. So your I1 is beta of m. What is m? 1 by 4, comma n. What is n? Sorry, 1 by 2 divided by 2. This is your I1. So let this be equation A or something. So we are going to use this formula 1 for the same second function. This is your formula that you are going to use for the second term I2. Remember, we have two integrals. This is I1 and this is I2. Now I'm going to find what is the corresponding value and then I'll multiply. Okay. So your I2 is nothing but integral 0 to pi by 2 root sin theta d theta. So which is same as 0 to pi by 2 sin power 1 by 2 theta, and there is no cos theta, same as this. We'll write cos power 0 theta d theta. Comparing with equation 1, we are going to use the same formula. See here, in the place of 2m minus 1, I have 1 by 2. The sin power is 1 by 2. In the formula, in the place of 2n minus 1, I have 0. From this can we find m, which implies 2m is equal to 1 plus 1 by 2. So 2m is equal to 3 by 2, which implies m is equal to 3 by 4. Okay, and then 2n is equal to 1, therefore n is equal to 1 by 2. You are going to substitute this I1 you have written beta of same thing you are going to write. I2 is also as per the formula beta of m comma n by 2. Same formula, right? See here, we are using the same formula. Whatever which is there on the right hand side is equal to beta of m comma n by 2. But in the second problem, m and n are different. What is m? 3 by 4. What is n? 1 by 2 by 2. This, let it be equation B. Finally, as per the question, you have to, one second, So, as per the question, you have to multiply I1 and I2. So, I'll write the question as I. Okay. So, if you see the question, see here. Your question is a combination of I1 and I2. Okay. Why it is not loading? So, I have written, see here, I1 and I2. You have to multiply. Yes, your I1 is here. Your I2 is here. You're just going to multiply, and what you have to prove, the final answer is pi. So your first I1 you got this answer. Your second I2 you got this answer. So I'm going to multiply these two. So I into I2. That is, just check your first answer. Beta of 1 by 4 into 1 by 2. 1 by 4 comma 1 by 2. By 2 is there, I think. Yes, by 2. So you can write it as 1 by 2. Into again second thing is beta of 3 by 4 comma 1 by 2. Just now we got it. Here it is. So 1 by 2 into 1 by 2 is 1 by 4. So what I have to do with this? Remember the relationship that we have proved between beta and gamma function. Gamma of m into gamma of n by gamma of m plus n. Remember, we are going to use this. So the first one is gamma of 1 by 4. Second one is gamma of 1 by 2 by gamma of 1 by 4 plus 1 by 2. Then this 1 by 2 I have multiplied and written. Gamma of 3 by 4, gamma of 1 by 2 by gamma of 3 by 4 plus 1 by 2. So we are just taking the LCM. So numerator, keep this as it is, gamma of 1 by 4, gamma of 3 by 4. This is gamma of 1 by 2, the whole square, divided by, so what you will do, will multiply numerator and denominator by the common factor, right, to get the common factor. So 2 plus 1, this is nothing but gamma of 3 by 4. Again, this is gamma of 5 by 4. And now, you can cancel this 3 by 4, 3 by 4. Okay. Gamma of 1 by 2 is what? Gamma of 1 by 2 is root pi. So we are going to use that. Root pi, the whole square will become pi. So what left here? 1 by 4. Gamma of 1 by 4 divided by gamma of 5 by 4 into pi. So what I can do with 5 by 4? You can write 1 plus 3 by 4. Correct? Gamma of n plus 1 is equal to n into gamma of n. We know this formula. Sorry, this is not 1 plus 3 by 4. Yes, it is 1 plus 1 by 4. Okay. So, gamma of n plus 1 is n into gamma of n. The place of n we have 1 by 4. 1 by 4 into gamma of 1 by 4. Now, if you see this, you are getting the same answer. 1 by 4 into gamma of 1 by 4 by 1 by 4 into gamma of 1 by 4 into root pi pi. So this and this will get cancelled and you will solution as pi. This is what we have to prove. So just use the required formula format. If the whole question is in terms of integral 0 to 1, something like that, then instead of using this formula format beta of m comma n, we'll be using the other formula, right? What is that? Beta of m comma n is equal to integral 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. So what is required? That formula accordingly you're going to apply. For example, if they ask 0 to pi by 2 root tan theta d theta. So now I can write it as 0 to pi by 2 root sin theta by root cos theta d theta. So which is nothing but 0 to pi by 2 root sin theta. I can write the sin power 1 by 2 theta. Denominator, if it comes to the numerator, cos power minus 1 by 2 theta d theta. So now it is so easy that you are going to compare with the same formula that you have mentioned. What is that? That equation. Yes, this one. Beta of m comma n by 2. In the place of 2n minus 1, I have plus 1 by 2. In the case of 2n minus 1, I have minus 1 by 2. Just substituting the values. In the place of 2m minus 1, plus 1 by 2. In the place of 2n minus 1, minus 1 by 2. And you can simplify and you can get the desired result by getting m and n. So you will get the answer as pi by root 2. Try this with the same format. And your question I is nothing but I can beta of m comma n by 2. Just you have to find what is m, what is n, substitute, same formula you use, that is the relationship between beta of m comma n, you will get the desired result. Thank you.